Hello viewers, I am Kausalya. Today we are going to solve problem number 4 under the category steady state error. The problem is consider a unity feedback system with the closed loop transfer function. The closed loop transfer function is given. Determine the open loop transfer function g of s. We have to find open loop transfer function from the given closed loop transfer function. Right. Also, show that the steady state error with the unit ramp input is given by a minus k by b. So the first thing is we have to find g of s. So this is our given problem. C of s by R of s is equal to Ks plus P by S square plus As plus B. Right. So in the problem they have clearly mentioned this is a closed loop transfer function. So what is the general representation of a closed loop transfer function? This is given by g of s divided by 1 plus g of s into h of s. Right. So this is the basic block diagram of a closed loop transfer function. So just in order to have a clear idea, I had drawn here. Right. The next thing, we have to find this open loop transfer function that is g of s. So in order to find that, we are moving to a new term. We are introducing a new term that is given as m of s. So this m of s is equal to g of s divided by 1 plus g of s into h of s. Okay, here we are assuming by ourselves, right? So the next thing, I am cross multiplying. So when you cross multiply, what happens here? This is m of s by 1, right? So 1 into g of s, and here this m of s gets multiplied by this term, right? So here I had written that step. The next thing is we are going to multiply. So m of s into 1 gives m of s plus again m of s into g of s gives m of s into g of s, right? Then I am rearranging the terms. So g of s, I am moving this g of s to the left hand side. So g of s here plus m of s into g of s becomes minus m of s into g of s, and this m of s remains here. Then in these two terms g of s is common. So I am taking that one outside. So the remaining term will be 1 minus m of s, which is equal to m of s. And finally the value of g of s is given by m of s divided by 1 minus m of s. Right. Now we are going to substitute the value of m of s. What is the value of m of s? M of s is nothing but, you see, m of s is nothing but c of s by r of s, right? We had replaced this c of s by r of s by a term m of s. So this c of s by r of s is equal to this ks plus p divided by this s square plus as plus b. So we can directly say that this m of s is equal to c of s by r of s, and this c of s by r of s is equal to ks, this expression, right? Therefore, we are equating this m of s is equal to this expression, right? Hope you people understand here. So here in the place of m of s, I am substituting this given closed loop transfer function, right? So m of s divided by 1 minus m of s. So here I am substituting accordingly. The next step is we are going to take LCM. So when you take LCM, this 1 gets multiplied with this denominator term. So here I am having s square plus as plus b minus of ks plus b, the whole divided by s square plus as plus b, right? Here both the denominator terms are same, so they cancel each other. And the next step is I am going to move this negative sign inside the bracket. So you see s square plus as plus b, when you move this negative sign inside, this becomes minus ks minus b, right? So the next thing is we are having 1 plus b term and 1 minus b term, so they cancel each other. And finally the remaining term is ks plus b divided by s square plus, you see here I am having s term, and again here also I am having s term. So I am taking this s commonly outside. So when I take this s outside, the remaining term is a, and here the remaining term is minus k. So here I am writing it as a minus k, right? And finally the next thing is here you see there is an s square and there is an s term. So I am taking this s commonly outside. When you take s outside, automatically the remaining terms will be s plus a minus k, right? So this is our value of g of s. And the next thing is they had asked to prove the value of steady state error. So to find the steady state error, what is the general thing? So they had in the problem, they had directly mentioned that, you see in the problem they had directly given the steady state error with unit ramp input. Okay, for a unit ramp input, we should prove that the steady state error value is this, right? So as they had given the type of input, we are using this velocity error constant because the input is ramp input. So this is given by the formula Kv is equal to limit s tends to 0 s into g of s into h of s. So we know the value of h of s is 1 because it is a unity feedback system, and the value of g of s we had already find out. So just substitute the values here. Once you substitute the value, you see these two s term get cancelled and the remaining terms are ks plus b divided by s plus a minus k, right? And the next thing is we have to substitute the value of s equal to 0 here. So when you substitute s equal to 0, this term reduces to 0. So 0 plus b, which is b, divided by 0 plus a minus k. And finally we are having the value of kv as b by a minus k, right? And from this kv we can calculate the steady state error. So the steady state error is given by 1 by kv, right? So the value of kv is known here. Just substitute the value of kv. It is b by a minus k. So when you move this to the numerator part, this becomes a minus k by b. This is the thing which is asked to prove and we have done now, right? Hope you people understand well. Thank you.